Today let's talk about rationalizing complex numbers. Now, something to remember is that since I is equal to the square root of negative 1, having I in the denominator of a fraction is basically considered unsimplified because it's like you're having a radical in the denominator. So when you come across a situation like that, like this one right here, 4 plus 3i over 2i, you need to get that I out of there. And so what you're going to do is you're going to treat that I just like it would be a radical. And if that was something like radical 3, what you would do is you'd multiply by radical 3 over radical 3 to rationalize the denominator. So we're going to do the same thing. So since it says I, I'm just going to multiply top and bottom by I. And so up on top, I have to distribute. So I'll get 4i plus 3i squared. At the bottom, I get 2i squared. Now you might be thinking, well, I still have i's in the bottom. Well, you're right. But we know I squared is equal to negative 1. So I can simplify more. 4i plus 3 times negative 1 over 2 times negative 1. Now I'm going to move it up over here. So if I simplify this, let's see, we get 4i minus 3 over negative 2. And you notice it says simplify into a plus bi form. So if I kind of switch this around, I would get final answer 3 over 2 minus 2i. Now if I lost you there, okay, what I did was, I'll kind of show you over here where I have a little bit more space. If I lost you there, what I did was I just switched around the negative 3 and the 4i. I split it up, and then I reduced. So this is 3 over 2, and then this is minus 2i. Okay, a plus bi form. Okay, that's something we should get used to. Now, take a look at number 2. Number 2 is a little different. Notice it says 11 plus I. Well, hopefully this might ring a little bit of a bell, okay, and that in order to solve this, if that's at 11 plus root 7, you would multiply by the conjugate, and that's exactly what we're going to do here. We're going to multiply by the conjugate, which is 11 minus I. So up on top, I get 55 minus 5i. In the bottom, let's see, do a little distributing, I get 121 minus 11i plus 11i minus I squared. So again, the whole point of a conjugate is that these middle terms go away, and these do. And here again, we have an I squared, so we're going to make that negative 1. So I get 55 minus 5i over 121 minus negative 1. So that becomes plus 1. So plus 1. So changing everything into a plus bi form, this would be 55 over 122 plus a negative 5 over 122i. Or that plus negative is actually quite unnecessary. You could write it as 55 over 122 minus 5 over 122i. But again, putting it into that a plus bi form. Okay, let's try one more. We'll just throw a little bit of everything at you. Here we have radicals and i's. So the method isn't any different. We're still going to go through and multiply by the conjugate, so let's do that. So 5 plus I root 6, 5 plus I root 6. So on top, if I distribute, I get 25 plus 5i root 6 plus 5i root 6 plus I squared root 36, which I know we'll be able to simplify that. On the bottom, you get 25 plus 5i root 6 minus 5i root 6 minus I squared root 36. So let's simplify a bunch of stuff. Let's see. Up on top, I know that this is negative 1. I know that's 6. So that'll be negative 6. So I'm going to get 25. There's a minus 6 from here. and then I can combine those. Down in the bottom, these go away. So again, I'm going to get minus negative 1, because I squared is negative 1, and 30 squared root of 36 is 6. So it becomes plus 6. So 25 plus 6. Simplify just a little bit more. On top, you get 19 plus 10I root 6. On the bottom, you get 31. Put it in A plus BI form, 19 over 31 plus 10I root 6 over 31. And there you go. There is rationalizing complex numbers.